Hello there. Today I'm just going to give a quick tutorial about how to calculate arc length, but more importantly, how to derive the formula for arc length in calculus. So in a arc length problem, normally what we want to do is we have some graph and we have some curve along that graph. And we're interested in calculating the arc length along this curve. So the line might go from some A to some value B. Okay. Now, as is often the case in calculus, it's easier to think about the summation, about discretizing this line into small little chunks and adding up those little chunks, and then generalizing to the continuous case. So that arc length, if you zoom really in, you can see that it's actually going to be, it could be approximated by just taking a lot of lines along this, just straight lines along this curve. So these are C1, C2, C3, and so on. And you can calculate those little lines using the Pythagorean theorem that really, C is equal to A plus B, right? Now, in our case, because B lies along the x-axis, okay, let me write this out. So arc length we're going to approximate as the summation of CI's. And we know that C, for all of the i's, so I'm just going to drop the I notation, is the summation of a squared plus b squared, square root, right? This is because of the Pythagorean theorem. So, but a lies along the y-axis and b lies along the x-axis. So really this is some small difference, some small distance in x, and this is some small distance in y, right? So then we can actually rewrite this as the small distance in x squared plus the small difference in y squared. Now we can simplify this a little bit by saying that, by pulling the dx out, right? So if we pull it out, it's 1 plus dy over dx squared times dx. So I kind of did two steps there. I pulled it out and then also pulled it out of the square root. Okay, so we're almost done here, but so far we are still using an approximation because of the summation, but using that summation I think has helped us really think about what we're doing. Now what calculus is as these little dy's and dx's get smaller and smaller, we move from the approximation to the actual value, right? And we can replace a summation with an integral because the integral is really just the continuous version of the summation. So s is going to equal the integral of 1 plus dy over dx squared. And there you have it, from A to B. The equation for the arc length is pretty simple to derive and hopefully makes a lot more sense when we've thought about it in the discrete case and then generalizing it. Thank you. See you next time.